Well, welcome to my short tutorial on the INS, Inertial Navigation Systems. So to define it, it's a navigation aid that uses computation, motion sensors or accelerometers, and rotation sensors, gyroscopes, to continuously calculate via dead reckoning the position, orientation, velocity, which is direction, speed and movement of a moving object without the need for external references. The 737-200 is such an aircraft that uses the INS. It's an aircraft flying well before GPS global positioning systems. So it uses inertial navigation as a self-contained navigation technique. Measurements provided by these accelerometers and gyroscopes and used to track the position and orientation of the aircraft relative to a known starting point, orientation and velocity. So hopefully I'll demonstrate in the next few minutes how you can set it up. Well, hello and welcome to the video. It's going to be a short tutorial style video on the CIVA Inertial Navigation System for the FlyJSim 737-200. It's also fully usable on the FlyJSim 727 Whisperjet, which we'll be looking at in a later video. So without more ado, here's the gauge installed. It's a nice 3D installation, and we also have a pop-up which can be moved anywhere on the screen. I'll leave the pop-up running and we'll concentrate on using the 3D gauge. So basically, before the introduction of GPS in civil aviation in the 90s and before the availability of modern flight management computers, SMCs, in the 80s, airliners were navigated mostly by means of radio navigation, VORs, as we've met in the previous video, DMEs and NDBs, and also inertial navigation systems. Radio nav can of course only be used when we're travelling over areas covered by the necessary ground installations. It can't be used for crossing the ocean. Inertial navigation instead is totally independent of external sources and it's totally self-contained in the aircraft. INS, Inertial Navigation System, are based on a principle already used, believe it or not, by Charles Lindbergh, dead reckoning. So perhaps the most famous INS was in the Boeing 707, the TriStar, the DC-10. The special variant was the Carousel 4, installed in Concorde and used to cross the North Atlantic at supersonic speeds. The name Carousel refers to the slowly rotating platform on which the gyroscopes are installed to cancel out false acceleration readings due to gyro precession. Although the unit looks primitive compared with modern FMCs, it's not an easy device to operate. It requires manual entry of 9 waypoints. It's the 9 waypoints on this system. Therefore it's usually necessary to reprogram the system in flight, but what I'll do, I'll demonstrate a flight just using 9 waypoints, which we'll enter manually. I think it's great fun entering it manually anyway. And it'll be a flight from Manchester to Innsbruck. Using PFPX Essential Kit because it gives us all the latitude and longitudes of our waypoints. So we'll be using this to input the data. So let's take a look at the CIVA for Explain. It consists of 2 panels. The upper part of the pop-up is the mode selector unit and the lower part is the control display unit, CDU. Normally the MSU is installed on the overhead panel of the aircraft while the CDU is in the centre pedestal. But to simplify it in this simulator, what they've done is just combine it into one window. Worth mentioning on the pop-up is you click in the upper left corner, you'll see a small K appears. This allows you to enter your coordinates using the computer keyboard, which is much easier, so we'll have a go at that. So to begin with, ensure that the CIVA is being powered by the AC power to the avionics bus in the aircraft you're flying. The CIVA can also operate up to 30 minutes from its own internal battery, which of course will get you down in case of an emergency, but it's not ideal to program. So we start by turning the lower data track to desired track STS and switch it on to standby. Next, check that the status mode is 0, not in nav, and no malfunction is displayed. Performance index is 9, the worst, and the desired performance is 5. So next we'll take the data selector to position. Now you have to initialize the position of the current ramp position of the aircraft. It's very important this, we've got to know where we're starting from. You get the coordinates from the airport chart. Alternatively, you can look them up. Well, we're going to be using the actual Manchester airport charts for gate 10, which is where we are at the moment. So I'll just show you exactly what's going on the other monitor. Here we have Manchester Airport and we have gate 10. So there's the coordinates: north 53.21.5, west 002.16.5. Okay. So the first thing you've got to do is to enter the position in the CDU, our current position. So we're in the northern hemisphere, so we select N for north, and we're pressing 2 on the CIVA pop-up, or on your keyboard on the computer. I'll use the pop-up on the screen here, and then you can see what I'm doing. Observe the insert button light up. Now enter the 5-digit sequence of latitude, degrees, minutes and tenths of a minute. If you make a mistake when entering, just press clear. So our position at Manchester gate 10 is north 53.21.2. So we've got north 53.21.2. Then press the insert button. The next thing you want to do is to select either west or east for the eastern longitudes. So we're west, so we hit west. So our western input is 002.16.5. And there you see it's put the decimal point in for you. Insert. Now comes the vital bit to align those gyroscopes. Make sure that you've set the parking brake on the aircraft and that we're not moving at all. Select the data selector to desired track and align. After selecting align on the mode selector, what you've got to do now is just wait for the countdown, watch it go through its alignment, and during the alignment the performance index will count down from 9, which is currently at 9, to 0. The total time it takes to this countdown depends on your latitude. The nearer you are to the equator, the faster the alignment will be. Now there is also a way to speed that up. So it's exactly the same as we did for entering the initial position. First select the latitude hemisphere, then enter the latitude, click insert, then enter the longitude hemisphere, enter the longitude, click insert, then verify the coordinates. So the first thing we do is turn the thumb wheel, which is this in the middle, to waypoint 1. So our first waypoint is, so here we go, we're going to enter our first waypoint on the route. It's going to be Coxie, Kilo, Oscar, Kilo, Sierra, Yankee. So remember, first of all, because it's the same as entering our current position, you need to turn the selector to waypoint and then select waypoint number 1. Zeros are our data entry. So first of all, select the hemisphere, northern hemisphere. And you've got to get this spot on. If you enter the wrong coordinates, the aircraft will fly all over the place. So we're north 51.057. 51.057. Insert. Next we want east because we've actually passed the datum. So we're going east 00239. Insert light lights up, click insert. Next waypoint is Kilo Romeo Hotel Karlsruhe. So again, it's north 48,59,6, insert, east 008351, 008351, insert, waypoint 3, lamb goal. So again, it's north 48532, insert, east 008467, insert, waypoint 4, Utaba. These are all waypoints, there's no VOR navigation beacon assigned to these, so we're relying upon the INS to navigate for us. North 48153, insert, east 00927, insert, and so on until we've got our 9 waypoints. So now we've reached waypoint 9, which is obviously our destination, Lowy, Innsbruck. So we'll enter that. It is north 47156, insert, east 001120, 6, insert, and that's waypoint number 9. And now we're ready to navigate. We're down to 5. This will count down to 0. When we're at 0, we're at optimum, and we can take off. So that's the inserting the flight plan manually. And you note that you can enter the waypoints while in standby, align, or nav mode. We've completed entering all the waypoints manually whilst the INS is still aligning. You can see it's now counted down to 4. And just to show you guys what I'm reading from, this is what I'm reading from on the other monitor. It's handy having a second monitor. Obviously the flight plan in PFPX starting from Manchester, going all the way down to Lowy, and I've selected the last 9, the last 7 waypoints. We'll start the INS, navigation at Coxey, Kilo Oscar Kilo Sierra Yankee, and I'll show you where that is on the map. Just as we've crossed the channel, we will see Coxey here, and then INS will take over. We will just monitor the VOR down to, well, we can set up Goosley in Belgium 115.7. won't be far off track there, but the next one is Dietrich 114.4 down to Karlsruhe 115.95, and then the final waypoints Lamgo, Utaba, Momok, Bemki, Zebix, Elmem. These are all just waypoint intersections, and then finally the inertial navigator will take us to Innsbruck, Lowy. All the time we'll be receiving ATC instructions for altitudes which we'll follow, but we'll allow the lateral navigation to be accomplished by the inertial navigator, which is what it's for, it's what it's all about. We'll be doing the vertical flying, and the INS will be doing the lateral flying. So that's basically how you set up the INS. Now of course there is a way to directly input into the CIVA the route that you have saved from, yeah, you guessed it, PFPX. But because the CIVA is only reading 9 waypoints. This is my amended flight plan just to go into the CIVA. So we've got Coxie, Karlsruhe, then Lambo, Utaba, Momok, Bemik, Zebix, Elmem, and then Lowy. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 waypoints. So this is how I do it. We're going to save this flight plan now, or rather export it. I will save it first and then we'll export it. As you can see in the export folder, I'm saving it into 2 FS9 flight plan folders, obviously for later use by MCE's Radar Contact 4, but the one we want is X-Plane folder, which saves it in the XFMC flight plans folder down here in X-Plane. But we want this one with just 9 waypoints, so we'll save that. 4 routes saved, and then as you can see the CIVA flight plan is a much simpler, straightforward 9 waypoint flight plan. These last ones being the most important for the CIVA, because we'll be on CIVA navigation from Coxie in Belgium. From Manchester to Coxie we'll be using VOR navigation, and then from Coxie INS navigation. We can load our original full route here, which is the longer one, obviously 683 nautical miles. And we can see we've gone back to VOR navigation to begin with. Tabley, Sid, down to Birmingham, Honley, Brookmans Park, Dover and Coxie. Altogether we've got considerably more than 9, but that's our original flight plan. Saving your flight plan from PFPX into X-Plane to be uploaded by CIVA INS, remember to put it into this folder: X-Plane, Output, FMS plans. If you have, like I have, the plugin XFMC, you've got flight plan folder there. That is not where you want to save your CIVA flight plan to. The CIVA won't look at it, it's looking at output FMS plans. Okay, so here's the quick way to upload your flight plan, having previously saved it with PFPX into the correct folder. Switch the unit on and hit remote. Then using the scroll wheel you will see all your loaded flight plans. An important note here, and a good note here, it will only load a 9-point flight plan. So the one that we flew earlier from Southampton to Newcastle is a 9-pointer, it loads that. There's the multi-point flight plan that's just not looking at, and of course here it is, the one we want: Echo Golf Charlie Charlie Lima Oscar India Whiskey India. And that's what we want, so we'll insert that and then check the waypoint. Obviously we need to set up where we are, but that's one: Coxie, Kilo Romeo Hotel, Lamgo, Utaba, Momok, Bemke, Zebix, Elmem and Lowy. And that is exactly what we saved. There you see it, that's what we've saved. Okay, So there we are. Hope you enjoyed the short tutorial on the CIVA INS, and hopefully we'll go fly it. Thanks for watching, and bye for now.